Hello and welcome to Andy's Code Vault, and welcome back to part 3 of my Tetris tutorial. Today I'm going to add object pooling and make some fixes to rotations and movement. So let's get started. The next thing I want to add is object pooling. And this is because I want to make the game run smoothly and efficiently. And what object pooling does is it allows you to keep objects in memory when you're not using them. Instead of instantiating objects all the time and destroying them back and forth, this object pooling will allow you to keep things in memory, and it prevents the garbage collection that happens automatically with C# from triggering. And what garbage collection is, it goes and deletes old memory while your game is running that you're not using. But if we keep all the references to all the objects when we're not using them, it'll make it so that garbage collection won't happen. So I'm going to create a new C# script, call it object pool. So the first thing I'm going to do is I'm actually going to make this not be a mono behavior, because this is going to be a class that's going to be called with inside of a mono behavior, inside our other objects, but it's not going to be attached to a game object specifically as a behavior. So I deleted the start and update methods. So I've created 3 private variables, class level variables. One is for the prefab. That's going to be the type of prefab that creates when it asks for a new one. The parent transform, so we're going to set the parent when we instantiate the prefab, and then a queue of game objects for the list of available game objects that we can use without having to instantiate or destroy the next one. So I've added 3 new methods. The first one is the constructor for the object pool class, and that's going to take in a prefab game object, the parent transform, and the count of how many objects you want to pre-warm or pre-instantiate, so that it's basically the estimate of how many objects you're going to use in this game. So we're going to load them up beforehand so that we're not instantiating objects as the game plays. So the first thing we do is we set the prefab to the class variable prefab and the parent transform. Then we're going to loop the count. So we're calling this return method and passing in an add object. So the add object is where you're actually instantiating the object and assigning it to the parent transform. It's also returning that object. So then it's going to pass that object into the return method. We're returning the game object back to the available list. So it's just a convenient way of adding it back into the list of available objects. And so when we're creating our initial count, we want to create the object and immediately return it. So in the return method, the first thing we're going to do is set the game object to be inactive, because we don't want it to be interacting with our game while it's inactive. And then we're setting the parent back to the former parent, because the parent could change. Like for instance, for the Tetramino piece, the parent's going to be the get next piece placeholder, and then it's going to be the board placeholder. But we're going to have a special placeholder for all of our object pool objects as well, so we need to reset it back to the parent transform. And then we're adding it back into the queue by calling the inQueue method and passing in the object. So now I've added the get method, and this is how we're going to get an object from our object pool. We're going to call the get method, and it's going to, well, if there's no available objects, it's going to add a new object. It's going to grab that object from the queue. If there is an available object, it's going to grab the object from the queue. It's going to set it to active, and then it's going to return the object. So now to implement it, we want to look for areas where we're instantiating and destroying objects. So I'm going to do a search for that. So here we're instantiating a new block. This is in the set Tetramino method where we're creating the new blocks. This is definitely a good place to use the object pool. And here's another one where we're instantiating the Tetramino pieces. So that's all we have. So those are the two items that we're going to use for object pooling. So I'm going to create a class variable called blocks pool, and that's going to be the object pool for the blocks. And I'll do the Tetramino later because it's a little bit more complicated, but let's do the blocks first. And I'm going to put in my blocks pool right here. I'm going to create a new object pool. I'm going to pass in my block template, and then I'm going to find an object called object pools objects, which doesn't exist yet. And I'm going to instantiate about 120 blocks. That was about my estimate about what an average game would look like during the game over scene. We would have about 120 blocks. So let's go ahead and create this object called Object Pools Objects. So I'm going to go into my container here and just create an empty and call it Object Pools Objects. And this is going to be just an empty game object, and I'm going to use to hold all the pooled objects. It's going to include all the tetraminos and all the blocks. All right, now let's go back to our instantiate method, and I'm going to go ahead and comment this out. So I'm calling new block is equal to the blockspool.get, so it's going to get the game object for me. Then I'm going to set the parent transform to the blocks transform, so it's no longer the object pools object as the parent. Now let's go look at the destroy method. So here we are in the clear lines method. So when we're clearing out the lines, we're going to destroy the game object after 1 second. So we need to, instead of destroying it, we want to return it back to the object pool. So let's comment this out. Okay, so now we're returning the block. However, before we were destroying the block after 1 second delay. We don't want to return it and have it be set active without that delay. So we need to add the delay into our object pool class. So let's do that right now. So I'm overloading the return method, and it's not ret run. That sounds like something Scooby-Doo would say. It's return. So I'm overloading the return method, and I'm going to add in a delay. So what I would like to do is be able to call the invoke method and then do the return, the other return, and pass in a delay. Or maybe call it a delayed return. However, I can't use the invoke method because invoke only works with mono behaviors. So I'm going to have to find just a generic C# way to do an invoke method. And in order to do that, I'm going to have to add a few using statements. So just the regular system and using system.threading.tasks. And over here, I'm going to make this an async method. And what adding an async to the method does is it basically allows you to work with the await keyword. And it's just a fancy way of doing asynchronous programming. And basically, whenever you want an await, you have to have an async. It has to be inside of an async method. And it's basically telling the compiler that this method is going to be able to be executed in multiple steps in a way, and it's going to be returned before the method actually gets completed calling. So it's kind of like a coroutine a little bit. Okay, so now we have our await, and we're calling this task delay method, passing in a time span from seconds using the delay. And then once the delay happens, it's going to call return object. So basically, this task executes, and then it's going to return the flow of control back to the container. Let's say when we call this here, passing in. So we're calling this method, and this is going to get returned. The flow of control is going to go back to this method before this return method even gets called. So it's kind of breaking up the flow of the code, but that's what the async method does. And the await, the async and await work together that way. All right, let's see if there's any more destroys. No. Let's take a look at our tetramino, see if they're doing anything with blocks. So there's destroying the game object, which is the tetramino. We'll do that next. We'll deal with that next. And again, it's destroying the game object. And that's it. Let's go ahead and run this and see if it works. So I'm going to pause it right here, and I'm going to look at this object pools objects. And as we can see, this is our 120 blocks that we're pre-instantiating. So we're going to be using these as your Tetris pieces pile up. Let's see if it works. Let's open this up again. Okay, I just noticed a bug here. We've got these invisible blocks over here. Why is that? Well, let's go figure it out. So the reason our blocks were invisible was because the fade out script is not stopping. So when we reuse our block that we've already used, that we faded out because we cleared the line, and now we're going to reuse that block again, the fade script never stops. So as soon as we reuse the block, it's going to start fading again or keep fading because there's no stopping to this. You see this in our update method. We have a flag here saying is fading. However, we're never setting is fading back to false. So we need to set it back to false once we're completed. Okay, so that's an easy enough fix. All we have to do here is check if the percent completed is greater than or equal to 1. We want to set the is fading to false. Now let's go back to our clear lines method in our container script, and I want to make sure that there's enough time for this delay to the fade out to complete. So I'm just going to add a 0.05 second delay to my block return. That'll give it a little bit extra time to go to complete, just in case the timing on this doesn't work out to 100%. It'll give us that extra 0.05 of a second, which should be enough to get it to be completed. All right, we'll test it again. So one thing I didn't realize was that even though I stopped the fading, I need to reset the color back to the original color. Okay, so instead of making this return delayed an extra 0.05 of a second, I decided to make this the actual fade out speed a little bit faster, so it completes the fade out before, because that 0.05 of a second wasn't fast enough. So this will make it, for the slowest animation, it'll be 0.09 of a second, which will guarantee it to run to completion. That seems to work much better. So now to create object pools for the Tetramino pieces. And what I actually need to do is actually make a list of object pools, because each Tetramino has a different prefab. So over here, I'm going to loop through all the different template types and then create a new object pool for each of the type of Tetraminos. And I'm going to create 2 Tetraminos because you have one in the placeholder and one in the active game object that's playing. So you need 2 of each type. Okay, now I'm going to look for where we instantiate the Tetraminos, and that is in the create next piece method. So I'm going to go ahead and comment this out, and then in here I'm going to grab the new Tetramino from the object pools using the index and the .get method. And the next thing I need to do is actually rotate it, because as we're moving the pieces and dropping the pieces, or the Tetraminos, they get rotated on the game. So I don't want them to be rotated when we reuse them, so I restore it back to the template's original transform rotation. Alright, now we need to find where the Tetraminos get destroyed, which is actually in the Tetramino script and not in the container script. So this is going to make it a little bit more complicated, because we have to destroy them in the container script or get reference to the object pools which are in the container scripts. So here's the first instance of where we destroy the Tetramino. It's actually in the run slide method. But what's convenient about this is we already have reference to our container and we're calling a game over method. So why don't we just pass in our game object where we can destroy it from the container. Okay, so now in our game over method, we want to add a new game object. I'm going to call it last Tetramino as a parameter to this method, and then we're going to want to destroy it right here. We'll do it right after we do our animation. Okay, so we want to use our Tetramino's pools and return our last Tetramino, but the problem is we don't know the index. So what I think I'm just going to add is a public variable in our Tetramino script to figure out which Tetramino piece we are. So over here in our Tetramino class, I'm going to add an index property with the get and set so that we can set it from the container script. So now in the create next piece in the container script, we should be able to assign that index to our new Tetramino object, because we know the index because we just pulled it from a random method, a random.range. So now in our game over, we can just grab that index from our last Tetramino by calling the get component Tetramino and then grabbing the index property value. All right, let's see if there's any more destroys here. So when the Tetramino falls to the bottom or falls on top of another Tetramino, there's another destroy right here. But again, fortunate for us here, we have a reference to the container right here calling the set Tetramino. So we're just going to pass in the game object right here. And then we no longer need to destroy it right here. Instead, in the set Tetramino, we can destroy it. Okay, so over here, I'm going to say game object Tetromino. So over here, I'm going to grab the script again, and then I'm going to grab the index, and then I'm going to return the Tetromino, essentially destroying it. However, there's one more thing I need to add here before we can destroy it, is the Tetromino has an active flag. It has its own internal is active right here. So we don't want it to be active whenever we do the get. And I don't want to add any specific code to the Tetromino here in the object pool. So we're going to have to add that. We're going to have to add a method to deactivate Tetromino before we return it. All right, so here I've created a public method called deactivate Tetromino, and we're setting that is active to false. And I want to do that here in the return method, and probably want to do it in the other location as well. So even though this is game over, we're probably not going to reuse it again. I still think I'll call that a deactivate method, just in case. Okay, so here I'm also deactivating the Tetromino right before every. Alright, one last thing I want to do here is I actually want to set the new Tetromino, the parent, to the next piece placeholder when we create the next piece. Alright, let's test this out and see if it works. Alright, I'm pausing it here. I'm going to look at our object pool objects. So we see all of our blocks. There's about 120 of them. And then over here we can see all our Tetrominos are in the object pool objects. We can see here is the L shape. We can see just one L shape. And then the T shape, just one T shape. So we're creating all these for our spares. And then we're actually using these two right now. Now as you watch me set this piece down. You can see the L shape has moved to the bottom of the list because I put it back in play. And then the O shape, it grabbed the next O shape here, and it's using that. So let's just play a little bit more and test it out, make sure everything's working. So the next thing I want to work on is I've noticed some issues with my rotations. The pieces are not rotating correctly. If you take a look, for instance, at the I shape, the rotation is based on this block right here. So it's going to rotate around this block. The first time it rotates, it's fine. It lines up in this vertical line. But then the second time you rotate it, it's going to move the shape over one length. And then you rotate it again, it's going to rotate it up. So there's a definite problem with that. It just doesn't look good when you're playing. It's moving the pieces around. If you look at the L and J shapes, they seem to be correct. I don't want to mess with these rotations. They seem fine. But the square piece is definitely not rotating correctly. If you look at it, I'm rotating around this block here, and it's just moving this piece all over the place. Same thing with this one. If you can see it here, it rotates fine the first time, but then after that it moves up, and then just moving around quite a bit. And the T shape's just fine, but the Z and S shapes are not correct. I came up with a solution. Let me show you that. What I'm going to do is just restrict the number of rotations. So for the I shape, I'm only going to allow it to rotate twice. So it rotates twice and then goes back to the original position. And then the square block, I'm just going to have it rotate once. I mean, not at all. It never needs to rotate the square piece. And the Z and S shape, I'm just going to rotate twice. T shape is going to stay the same. Okay, so I'm over here in the Tetromino script, and the first thing I'm going to do is create a new serializable field. And I'm going to set that to the max rotation, and then I think I'm going to clean up some of my old code here. I'm going to create a const. Okay, so I've set I have a new const here called single rotation, and I've set that to -90 degrees. That's to clean up some of the code that I've written before. So now I'm going to go into the rotate method, and the first thing I'm going to change is this -90. I'm going to replace that with the single rotation. And over here I'm going to do negative single rotation to do it back. So single rotation is -90 degrees. Negative 90 degrees is 90 degrees. Okay, so I actually made a lot of changes here. So the first thing I did was I grabbed the Z rotation from the Transforms Rotation Euler angles. And then I'm going to compare the absolute value of Z with the absolute value of the max rotation. And the reason I'm using absolute value is because I don't want to deal with negatives. Since both of these are negatives, if I want to change the direction of the rotation to positive in the future, maybe I'll like that better. I don't know. This way, I don't have to change this code if I change the direction. I just need to change the const single rotation and the max rotation values. So basically, if you go beyond the max angle, it just sets the rotation back to 0. And then else, it's going to do the rotation. If there's a collision, this is where I grab that Z and I use the Z to set it back to the previous rotation. Instead of rotating in the opposite direction, I just rotate it back to what it was before. And then of course I've still got my audio here. So let's give it a try. Okay, so the rotation shouldn't change on this piece. Let's test it out. 1, 2, 3, 4. That works perfectly. Now let's look at the eye shape. Okay, so 1, 2, 1, 2. That's what we want. It's not moving around now. That's good. And another eye shape, let's just drop it. And this one shouldn't change. And the center's always staying the same. That's good. Now this one should just do 2 rotations. That's good. That's all we want. We don't want it to move around as we're rotating. T-shape. Okay, something wrong with the T-shape. I'm going to have to check it out. The T-shape. Okay, so I forgot to set the max rotation. I'm going to set this to -360. I've done that. I've already done that for all these pieces here. As you can see, the I shape I've set to -180. J shape I've set to -360. L -360. This is 0 and should never rotate. S -180. T -360. And here -180. Let's try it again. Okay, so here's the T shape. And it's rotating 360. That's perfect. So my rotations are good now. Okay, so I think the next thing I want to work on is the controls. I think the controls aren't working as good as I'd like. I think it's just too slow to move it over. I don't want to make it faster on the first time you press. When you press down, I don't want it to move over 2 pieces accidentally. You know, I want precision. So I don't want to lose my precision, but I want to speed it up if you have to move it far. If you move it more than 1, I want it to move faster. So let's address that in the code. Okay, so I'm looking at my handle movement code, and I think this is where I want to implement the change in the delay. So I have it here as a constant movement delay. I think I'm going to change this to a variable, and then after the first move, then set it to be faster. Let me show you what I'm talking. So over here, I'm going to add a new const float called first movement delay equals 0.25. And we'll do fast movement delay equals 0.1. And then I'm going to delete this movement delay here. Actually, what I'm going to do is I'm going to set this movement delay. I'm going to rename it. I'm going to right click, rename m_delay. I'm going to apply all the changes. So this is going to update it twice in the code. And then I'm going to make it not a const, and then I'm going to move it out of my const area. Move it down here. Okay, and I'm going to set it to first movement delay, like that. So let's go back to this. Okay, we're in the handle movement, and that's fine. So what I want to do here is I want to do an else here, and I'm going to set my movement delay equal to the first movement delay, and then I'm going to go into my move, and I'm going to set this movement delay equals fast movement delay. What this is going to do is after I move, I'm going to say the next delay is going to be the fast movement delay. In here, if you move left or you move right, we have this if else and then else. So if you're not moving at all, reset it back to the first movement delay. That way it's not always going to be fast. So let's test this out and see if it works. Okay, move once. It's way too fast. I'm not getting my first movement delay. Why? The problem is right here, I don't want to set it to the fast movement delay until it's the second movement. I'm setting it on the first movement, because we don't really delay the first time you press the button. You delay it the second time. So let's add a counter here for the movement counts. So up here, I'm going to create a new private int called movement counts. I'm going to set it to equal to 0. And then in here, I'm going to set movement counts is equal to 0. And then I'm going to increment the movement counts. So if the movement counts is greater than 0, then we're going to do the fast falling. So let's give this a try. Single movement is working. And fast movement's working. Is that fast enough? Do I want it to be a little bit faster? Let's make it a little bit faster. Because when the game gets going, you want it to kind of move faster. So let's do 0.75. Let's try that. I think I like that. I'm going to play for a little bit and see how well this is working. Yeah, so it seems to be working pretty good. I think I'm going to keep it like this. That concludes this episode. If you like this video, please hit the like button. If you want to see more content like this, please subscribe. Thanks.